Good day, students. Welcome to a new learning experience. I am teacher Karen and I will be your math teacher. Today's lesson is all about greatest integer function. At the end of this video lesson, you are expected to define greatest integer function, graph greatest integer function, and cite real-life situation involving greatest integer function. Are you ready to learn? Then let's get started. Have you ever sent a money in any money remittance center? If so, you probably noticed that the service fee depends on the amount of money to be sent. For instance, suppose the money remittance center has its service fee listed as shown in the table. The service fee depends on the amount of money to be sent, so the service fee is a function of the amount of money. However, here's something interesting that is a little different from the functions we're used to seeing. Did you notice that the service fee for any amount ranging from 1 peso to 100 pesos is the same? So with 101 pesos to 300 pesos, and so on and so forth. For example, if you will send 910 pesos, you need to pay 15 pesos for the service fee. And if you will send 1,000 pesos, you will also pay 15 pesos for the service fee. In mathematics, this is a special type of function called greatest integer function. Greatest integer function, also called step function, is denoted by f of x is equal to the greatest integer function of x and is defined as the greatest integer less than or equal to x. Greatest integer function rounds up the number to the nearest integer less than or equal to the given number. The greatest integer function takes an input and the output is given based on the following two rules. If the input is an integer, then the output is that integer. If the input is not an integer, then the output is equal to the next smallest integer. So, if we are given a number, say 18, and we plug it into the greatest integer function, we would get 18 back since 18 is an integer. On the other hand, if we are given a non-integer number, say 5.27, the output would be equal to the next smallest integer, which is 5. Here are some more examples of greatest integer function. The greatest integer less than or equal to 17.2 is 17. The greatest integer less than or equal to 27 is 27. The greatest integer less than or equal to 99.9999 is 99. And the greatest integer less than or equal to 9.27 is 9. What is the greatest integer function of negative 2.5 equal to? Very good! The greatest integer less than or equal to negative 2.5 is negative 3. As clearly seen from the given examples of the greatest integer function earlier, the input variable x can take on any real value. However, the output will always be an integer. Also, all integers will occur in the output set. Thus, the domain of the greatest integer function are the set of real numbers, while its range will be the set of integers. Example: what is the domain and range of the greatest integer functions f of x is equal to 1 over the greatest integer less than or equal to x, and g of x is equal to 2 times the greatest integer less than or equal to x. In example A, the denominator should not be equal to 0. Thus, the domain are the set of real numbers except 0, and the range are the set of integers. While on example B, the domain are the set of real numbers and the range are the set of integers. Alright, we've got this greatest integer function concept down. This time, we will explore on its graph. What do you think is the graph of a greatest integer function? Exactly! Greatest integer function is not called a step function for nothing. Its graph is known as the step curve because the structure of the curve resembles the steps in a staircase. Plotting the graph of a greatest integer function is easy. First, consider f of x is equal to the greatest integer less than or equal to x. If x is an integer, then the value of f will be x itself. If x is a non-integer, then the value of x will be the integer just before x. For example, for all numbers lying in the interval 0, 1, the value of f will be 0. For the entire interval 1, 2, f will take the value 1. For the interval -1, 0, f will take the value -1 and so on. So, for an integer n with interval n plus 1 will have the value of the greatest integer function as n. The function has a constant value between any two integers. As soon as the next integer comes, the function value jumps vertically by 1 unit at each integer value. This means that the value of f at x equals 1 is 1 and not 0. Hence, there will be a hollow dot at 1, 0 and a solid dot at 1, 1, where a hollow dot means not including the value and the solid dot represents including the value. When graphing any function, it is helpful to construct a table of values that satisfies the conditions of the given function. Let's work on graphing f of x is equal to the greatest integer less than or equal to x by constructing first a table of values. On the first column of the table are the values of x for each interval. If x is equal to -2, then the greatest integer less than or equal to -2 is -2. And if x is equal to -1.5, the greatest integer less than or equal to -1.5 is still -2. Same when x is equal to -1.9. The greatest integer less than or equal to -1.9 is still -2, and so on with the next interval. The graph for the first two intervals is shown on the right. Notice that the right endpoint of each step is an open circle or a hollow dot, which means not including the value. Here is the graph for the greatest integer function f of x is equal to the greatest integer less than or equal to x in the interval from -2, -1 to 2, 3. Here is another example. Graph the greatest integer function f of x is equal to 2 times the greatest integer less than or equal to x minus 1. To evaluate the given function, substitute the values of x in each interval into the given function. If f is equal to 0, the value of the given function is -2. If f is equal to 0.4, the value of the given function is still -2, so on and so forth. The table of values for the greatest integer function f of x is equal to 2 times the greatest integer less than or equal to x minus 1 is shown on the table. Plotting the values in each interval, we come up with the graph shown on the right. Greatest integer function is evident in the real world. Say for example your cell phone plans. You pay one price for a specific number of minutes. If you want more minutes, you pay more money. Think of each step as a plan. Another example is the post office. You pay postage to mail things based on their weight. One stamp allows you to mail something that weighs up to 17 ounces. Past the 17 ounces, you must add another stamp. Think of each step as representing the weight you can mail per stamp. We have now learned about the greatest integer function, and that includes its fundamental definition, properties, and even its graph. We are now ready for some practice exercises. But before we do so, let's summarize what we have learned so far. The greatest integer function, also called step function, is a piecewise function whose graph looks like the steps of a staircase. The domain of this function is the set of real numbers, while its range is the set of integers. It is denoted by f of x is equal to the greatest integer less than or equal to x and is defined as the greatest integer less than or equal to x. It rounds up the number to the nearest integer less than or equal to the given number. For your activity, in a graphing paper, construct a table of values and graph the following functions. Number 1. F of x is equal to 2 times the greatest integer less than or equal to x. Number 2. G of x is equal to the greatest integer less than or equal to x minus 2. Number 3. H of x is equal to 3 times the greatest integer less than or equal to x plus 4.
And that's it, my dear students. I hope you learned something today. Once again, I am Teacher Karen saying, stay at home, stay healthy, keep safe, and God bless. See you on our next video lesson. Bye-bye!